Hello everyone, this is Otutochi Caleb Nwadimpa from Special Maths Academy, and in this video we'll be solving the problem 4 of the Pan-African Mathematics Olympiad 2023. So here we are told that Manzi has end stamps and an album with 10 pages, and he distributes the end stamps in the album such that each page has a distinct number of stamps. He then finds that no matter how he does this, there's always a set of 4 pages such that the total number of stamps in these 4 pages is at least n over 2. And now we are asked to determine the maximum possible value of n. So firstly, let's call the number of stamps in the first page n1, the number of stamps in the second page n2, we have n3 and n4 all the way to n10. So n stamps are distributed in the first place. So consequently, we'll have that n1, the sum from n1 to n10 is equal to n. Right. Also, we can take notice that the order of the pages don't really matter. Even if we shuffle the pages, it's not going to change the outcome if there's always a set of 4 pages, so that the total of these 4 pages is greater than or equal to 1 over 2. The set of 4 pages will still be there, and if there's not, then there won't be. So shuffling doesn't actually change the outcome. So for that we can now set a particular order that will actually be beneficial to us. So we can assume that without loss of generality, that n1 less than n2, n2 less than n3, n3 less than n4, n4 less than n5, n5 less than n6, n6 less than n7, that less than n8, that less than n9, and less than n10. And we are good. Also, we are looking at we want to find a set of 4 pages, or we are looking for a set of 4 pages such that the total number of stamps is greater than or equal to n over 2. And for that, we only need to consider the biggest 4, right? We only need to consider this sum, n7 up to n10. Now, if for any particular distribution, if the sum n7 up to n10 is not greater than or equal to n over 2, then you know that there's no set of 4 pages because that's the biggest, right? So if the biggest is not greater than or equal to n over 2, then you can get that there's no set of any other 4 pages. There's no any other 4 pages that will give you something greater than or equal to n over 2. But if it is, then you already have your set of 4 pages and you're cool. So considering this is enough. Also, remember that for a given n, we can choose n1 to n10 under these conditions in a lot of ways, right? And the problem actually tells us that there has to be this set of 4 pages, no matter how he does this. So we actually want n7 up to n10 to be greater than or equal to n over 2, no matter how we choose n1, no matter how we choose the nk or the ni, right? So to do this, a better way of looking at it is to actually consider the distribution, the actual distribution such that this value is minimum, right? This sum n7 from the sum of n7 to n10 is minimum. So now, for a given n, if the value is, if for a given n, if we consider the distribution such that this value is minimum, if that value there is greater than or equal to n over 2, then we know that that value is going to be greater than or equal to n over 2 in all other distributions, and it means that that n works, right? But if it's not, then we know that for one distribution, we won't be able to find a set of 4 pages such that won't be able to find a set of 4 pages such that the total number is at least n over 2, and we know that that n doesn't work. So basically, we just need to consider we just need to consider this value in that distribution, and we'll call that distribution the ideal distribution, right? The ideal distribution. Let's call that distribution the ideal distribution, and that's the distribution that has the minimum value for n7 plus n8 plus n9 plus n10. So like I say, for each n, we'll consider that value in the ideal distribution. And if it's greater than or equal to n over 2, then that n works, else that n doesn't work, right? So secondly, Manzi distributed the n stamps among 10 pages, and we are told that each page has a distinct number of stamps. Now, the lowest 10 numbers are 0 to 9, right? Of course, you can't have negative numbers, right? Because you can't have a negative number of stamps. At least you can have a 0, which is no stamp at all. So that means that the least value n can be, whether it works or not, is the sum of these guys. Because we can't have if there's any n that is not up to the sum of these guys, then we won't be able to distribute it among 10 pages according to these rules, right? So basically we'll have that n is greater than or equal to 45, and consequently we can express n as 45 plus t, such that t is greater than or equal to 0, right? So now we can now take 45 as a base number and deal with only t, right? You can take 45 as a base number and deal with only t. And to do that, there are 10 pages, so it makes sense to take t to be equal to 10k plus L, right? And of course, that's going to make n equal to 45 plus 10k plus L. Of course, k is greater than or equal to 0 and L is greater than or equal to 0. If they are both 0, go back to 45, which is the least number, and that's fine. So now basically for all n, we express that n in this form: 45 plus 10k plus L. And of course, L is less than or equal to 9. If it's up to 10, then that just adds 1 to k, right? So express any n in this form, and with this form we'll be able to determine the ideal distribution and consider the sum from n7 to n10 in that ideal distribution. And if it's greater than or equal to n over 2, then that n works, else we know that that n doesn't work, and that will help us finding the maximum possible value of n. So we are going to look at this in two cases. The first case is, of course, L is between 0 and 9. The first case is 0 less than or equal to L less than or equal to 9. And the second case is less than or equal to 4, right? And the second case is 5 less than or equal to L less than or equal to 9. So first, to look at the second case, right? Of course, we have n. Of course, we have n is equal to 45 plus 10k plus L. And then you are just going to have 0 less than or equal to L less than or equal to 4. Right? So at this point, I'll drop a claim that the ideal distribution for this case is k plus 1, k plus 2, k plus 3, k plus 8, k plus 4, k plus 5, k plus 6, k plus 7, k plus 8, and k plus 9 plus L. Right? I'm dropping a claim that this is the ideal distribution, and I'm going to prove it. Of course, an ideal distribution is not unique, right? That means there can be more than one ideal distribution, but the main point is let the value of this be minimal. So as far as the value of this is minimal in that distribution, then it's ideal, right? This is just what we care about. So there can be different distributions that have the same value for this guy to be minimal, and they'll all be ideal distributions. So I'm just claiming that this is one of them, and that's basically saying that this sum here is minimal, right? And to prove that, I'm going to go through proof by contradiction. So I'm going to assume, right, or let us assume that there's another distribution n1, n2, n3, n4, n5, n6, n7, n8, n9, and n10, right? So now I'm assuming that there's another distribution such that the value of this guy is n7. The sum n7 to n10 is actually less than the sum of these guys, right? And the sum of these guys is 4k plus 30 plus L, right? So this is an assumption. So now we are going to look at n7 now. In this second distribution, in this assumed distribution, we are going to look at n7. N7 can either be less than k plus 6, equal to k plus 6, or greater than k plus 6. So for the first case, if n7 is less than k plus 6, right? That's just going to imply that n6 is less than, that's going to imply that n7 is less than or equal to k plus 5, right? So that's going to imply that n6, because of course this is ordered, we know that n6 is less than n7. So that will imply that n6 is less than or equal to k plus 4. And this in turn is going to be less than or equal to k plus 3. This is going to be less than or equal to k plus 2. This is going to be less than or equal to k plus 1. And this is going to be less than or equal to k. This is going to be less than or equal to k minus 1. So that just means that n1, the sum n1 all the way to n6 is going to be less than or equal to the sum of these guys here. So of course that's 6k plus 9. Now remember that this sum n1, the sum from n1 to n6 plus the sum from n7 to n10 is equal to the sum of n1 to n10, which is n by definition. So if we have this going to be less than or equal to 6k plus 9, then this is going to imply that the sum from n7 to n10 is going to be greater than or equal to n minus that, right? So basically, if you do n minus that, it's going to be 10k minus 6k, which is 4k. We have 45 minus 9, which is plus 36. And then we have plus L, right? Which is definitely greater than this guy. And we have already assumed that n7 plus n10 is less than this. So there's a very big contradiction here, right? So the next case is n7 greater than k plus 6. Now, if n7 is greater than k plus 6, this is just going to imply that n7 is greater than or equal to k plus 7. And of course, it's ordered, so that's going to imply that this is greater than n8 is greater than or equal to k plus 8. This is also going to imply that n9 is greater than or equal to k plus 9, and this is going to imply that n10 is greater than or equal to k plus 10. Right, so this is just going to mean that the sum there, n7 up to n10, is greater than or equal to the sum of these our friends here, and that's 4k plus 34. Now we already have that L. We already have that 4 is greater than or equal to L. So this is definitely greater than or equal to 4k plus 30 plus L, right? But then we already assumed that n7 all the way to n10 is less than this. So we have another very big contradiction here. And finally, if n7 is equal to k plus 6, right? If n7 is equal to k plus 6, that's just going to imply we'll do something similar to that. We have actually merged the two cases together, and we'll do something similar to that to give us n7. If this is equal to k plus 6, we'll have n6. We'll have, of course, n6 is going to be less than or equal to k plus 5 here, right? This is going to be less than or equal to k plus 4. This is going to be less than or equal to k plus 3. This is going to be less than or equal to k plus 2. This is going to be less than or equal to k plus 1. And this is going to be less than or equal to k. So we'll just be looking at their sum there, right? And that means, so this is just going to imply that the sum n1 to n6 is less than or equal to 6k. plus 15. So this is basically what we did before. We could have actually merged the two cases together and it would have made no difference. So just imply that the sum of n7, the sum from n7 to n10 is going to be greater than or equal to n minus that, which is 10k minus 6k is 4k, and plus 45 minus 15 is 30. Then we have our friend L here. I've already assumed that it's less, so we have another big contradiction here, right? So that means, so from this we got that if there's actually an ideal distribution that is less than this, then n7 cannot be less than k plus 6, n7 cannot be greater than k plus 6, n7 cannot be equal to k plus 6. So there's a total contradiction, right? Which means that this is not even possible in the first place. So we have that our big friend here is an ideal distribution, and this guy here, the sum of these guys here is minimal, right? So because the sum of these guys there is minimal, we can use it to test for the values of n that will work. And of course, those are the values for which that sum is greater than or equal to n over 2. So we basically have to test for that, we'll get that 4k plus 30 plus L should be greater than or equal to n over 2. And that's just equal to, since n is equal to 45 plus 10k plus L, this is going to, n over 2 is going to be equal to 22.5 plus 5k plus L over 2, right? So if you leave k at one side, you're going to get that 30 minus 2.5 is 7.5. L minus L over 2 is plus L over 2 is greater than or equal to k, or in other words, k is less than or equal to 7.5 plus L over 2. So we can actually work with this and get a value for n. We just need to plug k in for n and get a maximum value for n. But what's going to happen is that's not going to be a value, that the inequality is not going to be compact enough. So to make the inequality tighter, because this is just an inequality, right? There's no guarantee that k actually is up to this number. We just know that k is less than or equal to that. The maximum k can actually be less than this. So to make the inequality tighter, let's divide this into odd and even L. So this is odd L, and or let me call this even L. This is even L, and then this is odd L. The reason for this is that if L is even, then we'll have that L over 2 is going to be an integer. L over 2 is going to be an integer. So and then that means you'll definitely be having k is less than or equal to 7 something 0.5, right? This is an integer plus 7.5. So you'll be having k less than or equal to something 0.5. But that's not tight enough, because k cannot be equal to 7.5 since k itself is an integer. So it means that for this case, even L, to make things tighter, we can actually remove the 0.5, and then the inequality is going to be tighter, right? So for this case, we'll get that k is less than or equal to 7 plus L over 2. And then for this case, 0.5 and plus 5, 0.5 from here, and then L over 2 will also give another 0.5. So they'll add up to an integer, and that's fine for k. So we'll leave it that way. K is less than or equal to 7.5 plus L over 2. Now we'll treat the two cases separately. So these are the two cases under that first case now. So of course, we have that n is equal to 45 plus 10k plus L. So if k is less than or equal to this, then basically n is less than or equal to 45 plus 10 times 7 plus L over 2 plus L. And this is 45 plus 70 plus 5L plus L. And this is 115 plus 6L. And the maximum L can be, in this case, is 4. So basically we have 115 plus 24, which is 139. So this is the maximum n in this case, right? And then in this case, we have that n is less than or equal to 45 plus 10 times 7.5 plus L over 2 and then plus L. And we have that that's going to be just going to be equal to 45 plus 75 plus 5L plus L, and that's going to be equal to 120 plus 6L. Now, this is the case where L is odd, so the maximum L can be is 3. 6 times 3 is 18 plus 120 is going to be 138. So the maximum here is 138. So of course, the total maximum in this case is 139, right? But we'll leave them separate for now. This is because we're actually looking for, we'll also, for the second case, we'll also divide it into two cases, and then each will have their own maximums. So actually, the point is actually trying to make sure, we are trying to make sure that we can actually reach these numbers, right? For example, if we get 139 to be the maximum out of all four cases, we have to make sure that we can actually get up to 139. We have to find a case to give us up to 139. That's where L is odd. That's why we have to keep it separate for now. So we have to find a case where L is even, where L is even, that will give us 139. Or for whatever maximum number there is. Else, we may just be having a less than or equal to, but we won't really get the maximum number. So we can, with this, we can move to the second case, right? And that's the case of course, N0 remains 45 plus 10K plus L. And this is the case of 5 is less than or equal to L, less than or equal to 9. So for this case, basically we have this as the base, right? We have K plus 7, K plus 8, K plus 9, and K plus 10. Right, so basically, and we have K plus 1, K plus 2, K plus 3, K plus 4, and K plus 5. Okay, for this case, this case is not just a matter of adding L. This is my claim for the ideal distribution, but it's not complete yet. So this case, basically what's happening here is that for this now, what we have here now is actually 45 plus 10K and plus what we have here is actually 45 plus 10K plus 4. That's the sum for now. So we just have plus 4, but we need plus L, right? So if L is 5, 1 is missing, we'll just add it to this guy. If L is 6, then there are 2 missing. We'll add 1 here, we'll add 1 here. If L is 7, there are 3 missing. We'll add 1 here, add 1 here, and add 1 here. If L is 8, we'll add for this 4, and if L is 9, we'll add for this 4. And that's my proposal for the ideal distribution. But in this case, whatever L is, this still doesn't change, right? This is still, the sum is still 4K plus, if you add this up, plus 34. And I'm proposing that we can get another distribution that will give us less than this, right? So similar to what we did, we'll try to prove by contradiction. Let's say we have an N1, N2, N3, N4, N5, N6, N7, N8, N9, and N10. Let's say we have another distribution such that the sum N7 plus N10 is less than 4K plus 34, right? We are trying to show that this is not possible. Of course, if N7, if N7 is greater than or equal to K plus 7, right? If N7 is greater than or equal to K plus 7, we'll just have that this sum, just have that, of course, because of the offsets, we have that N is greater than or equal to K plus 8, N is greater than or equal to K plus 9, N is greater than or equal to K plus 10, which means that this sum will just be greater than or equal to this, right? This implies that greater than or equal to 4K plus 34, but we have already assumed it's less than, so there's a big contradiction here. So just take the other case, which is n7 less than k plus 7, and then we're going to do something similar. This is going to imply that n1 to n6 is going to be less than or equal to, of course, if this is less than k plus 7, less than or equal to k plus 6. So basically, you have this less than or equal to k plus 5, less than or equal to k plus 4, less than or equal to k plus 3, less than or equal to k plus 2, less than or equal to k plus 1, and less than or equal to k. And if you take the sum of that, it's going to be 6k plus 15. So of course, this is going to imply that n7 to n10 is greater than or equal to n minus this, and that is going to be 4k plus 30 plus L. And of course, we already have that L is greater than or equal to 5. So this is, yes, 4k plus 45 minus 15 is 30 plus L. I already have that L is greater than or equal to 5. So this is definitely going to be greater than or equal to 4k plus 35. So there's a contradiction there. And that means, and that takes us back to, this is going to be our ideal distribution. So we'll just do something similar. We already have this to be the value for the biggest four numbers. So we'll just do something similar. We want this, so we'll check the case of when this is greater than or equal to n over 2. So we have 4k plus 34 greater than or equal to n over 2 is 22.5 plus 5k plus L over 2, right? So that's we want k alone. So 34 minus 22.5 is 11.5. Then take L over 2 to the other side is L over 2 greater than or equal to k. And that's the same thing as k is less than or equal to L, 11.5 minus L over 2. So again, we are going to divide this into 2. We are going to have odd L, and we are going to have we're going to have even L. We are going to have odd L, right? So even L and odd L. The even L part makes it tighter. So we are going to have here k is less than or equal to 11 minus L over 2 similarly. And then for this case, we are going to have k is less than or equal to 11.5 minus L over 2, and also that's also an integer, so we are good. So basically, what we have here is, of course, L is between 5 and 9. So basically, you have minus 5 greater than or equal to minus L greater than or equal to minus 9. So you have minus 2.5 greater than or equal to minus L greater than or equal to minus 4.5. So in short, sorry, minus L over 2. So in short, we have minus L over 2 is less than or equal to minus 2.5. So we have that minus L over 2 is less than or equal to minus 2.5 in this case. That's if L is even, right? But that's for odd L, right? But for even L, this is going to be 6, right? So we have minus 3. So basically, for this, we're going to have, let's just finish this. I'm going to have n is going to be less than or equal to 45 plus 10 times 11 minus L over 2 plus L. And here this is going to be equal to 45 plus 110 minus 5L plus L, right? And this is going to be equal to 155 minus 4L, right? And then this is going to be equal to, this is going to imply that n is less than or equal to 45 plus 10 times 11.5 minus L over 2 plus L. This is going to be equal to 45 plus 115 minus 5L plus L. And this is going to be equal to 160 minus 4L. So again, let's go back to this. Not really this. Let's go back to this. For this case, the smallest L we can have is, the smallest even L is 6. So basically, it will just be, so basically N is less than or equal to 155 minus 4 times 6, which is 155 minus 24, which is 131. Right? And for this case, the smallest odd L we can have is 5. So this is just going to be giving us N is less than or equal to 160 minus 4 times 5, which is 160 minus 20, which is 140. So you have this as the maximum here and this as the maximum here. And of course, we compare that to the other maximums we have in other cases, 139 and 138. And the maximum out of all of them is 140. Right? So, but like I said, we actually have to check that this can actually reach 140, right? And then to do that, we'll just take the case we have. Basically, like we said, the list here happens when L is the smallest, right? When you're subtracting the smallest number, right? So that's when N is maximum, right? So check when L is smallest, which is when L is 5, right? And when L is 5, L over 2 is minus 2.5. So we have K is equal to 11.5 minus 2.5, which is 9. So we have K is equal to 9. And we'll do what we did. We'll check the distribution that we did then. We have 9, 9 plus 1, 9 plus 2, 9 plus 3, right? 9 plus 4, 13. 9 plus 5 is 14. Yeah, and then from the back, the other side, we have 9 plus 10, which is 19. 9 plus 9, 18. 9 plus 7. 9 plus 8, 17. And 9 plus 7, 16. This for the other side. And of course, L, as we said, L is 5. So like I said, L is 5. You just be adding 1 to this guy. And that's going to give us 15. All right, so this is the distribution that from our calculations should give us the maximum. But we have to, we want to check whether we can actually get that maximum. So just check that 9 plus 10 is 19, plus 11 is 30, plus 12 is 42, plus 13 is 55, plus 15 is 70, plus 16 is 86, plus 17 is 13, plus 18 is 121, and plus 19 will give us 140. So this is actually 140. So we have shown that N is less than or equal to 140. And you have showed a distribution from my proof. We know that this is actually an ideal distribution. So if we have shown a distribution that is an ideal distribution, and we have shown that I can actually get a value when N is 140. And since this is an ideal distribution, we have also shown that the sum of these guys will be greater than or equal to N over 2. So definitely 140 is going to be a maximum N. And that is the solution for this problem. Maximum N is 140. So thank you for being patient to the end of this video. See you in the next. Bye bye.